All right, let's go ahead and move on with our discussion on parallel lines. In the last section, we talked about if we had parallel lines, what could we say about different angle pairs? So if the lines were parallel, and so this is the key here, if we have parallel lines, then we can say corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. So that is determined by making sure that we actually have parallel lines to begin with. So if I have two lines and I know they're parallel, so they give me the markings, then any of those angle pairs, like alternate exterior here, would be identical. The only kind of weird angles from yesterday were when we talked about same side interior. So same side interior angles were supplementary, meaning if I put one angle with its same side interior, these two angles had to add up to 180 total. Okay, so the main thing from the last section was that if I have parallel lines, and that's the key, I have parallel lines to start, and because of that, I can then say corresponding are congruent. I can say alternate interior are congruent. I can say same side interior are supplementary. So if I have the parallel lines first, then I can say all the angles are the same. Now today, we're going to reverse that. So we're going to talk about the converse statements. So today, we do not know if the lines are parallel to begin with. So I have to show that corresponding or alternate interior or alternate exterior angles are congruent. If I can do that, then I can say my lines are parallel. So you're going to start with a situation like this. Okay, so no markings. These two lines may or may not be parallel, we don't know. So what we would have to know ahead of time is like, are any of the angle pairs the same? So for instance, if they told us that this top angle up here was 100 degrees, and then this angle here was 100 degrees, well, these two angles are corresponding angles. And so those corresponding angles are congruent, and so we have this first statement, these two lines must be parallel. So if we give these names, A and B, for instance, because of those corresponding angles, A must be parallel to B. But without that information, there's no way to make the determination that we have parallel lines. So today we're starting with, okay, we're trying to show the lines are parallel. We can only do that if we have corresponding angles or if we have alternate interior angles that are the same. And then like we said, the weird ones, the same side interior angles are supplementary. So if I can show that those angles add up to 180, then I can say that the lines are parallel. So yesterday, the lines were parallel to start. We used that to set up and solve for our missing angles based on the relationships. Today, we don't know anything about the lines. So we have to look at the angles and see what they tell us. And if they're the same or if they add up to 180, then we can say that the lines are parallel. So the other thing, real quick to talk about, is kind of an extension of one of the properties we discussed in chapter 2, which is that transitive property. If one thing leads to the next and that leads to the next and one leads to three, that middleman property. Well, that also works for parallel lines. So if I'm telling you that P and Q are parallel, but then I tell you, or turn around and tell you, well, that Q and R are parallel. So because P was parallel to Q and Q was parallel to R, then P must also be parallel to R. Like all three of those lines have to be parallel to each other. So that transitive property applies to parallel lines as well. P led to Q, Q led to R, so P and R, they're going to be the same. Okay. Now, as far as applying the information we just kind of talked about here, in this example, they want us to know. So in this picture, they want to know which lines are parallel using the following information. Now, as of right now, these lines are not parallel to each other. There is no marking that says A is parallel to B, or no marking saying L is parallel to M. So we can't just assume because they look parallel that they are. We have to have specific information to make that determination. So if we look here, the first thing they tell us in problem number 1 is that the measure of angle 1 equals the measure of angle 3. So what I would suggest doing on these types of problems is mark your picture. Angle 1 and angle 3 are the same. Now, as far as which lines have to be parallel, well, if we think about this in the picture, these angles have nothing to do with line M. Like, neither angle touches line M at all, which means I can't be talking about L to M. So if I look at the only way these angles can travel, it would be from A to B. So if I look at these angle pairs, they are corresponding angles, which means I can say A is parallel to B because corresponding angles were congruent. So when you're doing this, it said justify your answer. Your justification is whatever angle pair they gave you. So A is parallel to B because they gave us corresponding angles that were congruent. Okay. Now, with the next problem then, similar idea. So we're going to go ahead and, for number 2 here, so for number 2 it says measure of angle 2 is equal to the measure of angle 5. So these two angles are identical. And so again, if we kind of look at the picture here, these two angles have nothing to do with line B. So right now, A and B are out of the conversation as far as parallel. So that means I need to be looking at L and M. Well, so if I look at these two angles, those two angles are alternate interiors. So line L would be parallel to line M because I have alternate interior angles that are congruent. So if I have an angle pair that I know about and I know they're congruent or supplementary, I know that those angles, or the lines that they touch, have to be parallel. And so if we look at the next one, so if we look at number 3 here, angle 3 plus angle 7 equals 180. So here's angle 3, here's angle 7. It's saying that those two angles are going to add up to 180. Now again, these two angles, 3 and 7, have nothing to do with line A, for instance. So that means right now I'm talking about L and M. So if I look at these two angles here, those are my same side interiors, and they tell me that they're supplementary. So line L must be parallel to line M because same side interior angles were supplementary. So which lines are parallel? So that's the easy part. Which two angles, or which two lines do the angles touch? And then how do you know? So which type of angle pair did they give you? Did they give you corresponding or congruent, alternate interior congruent, same side interior supplementary? So you just got to kind of figure out which angle pair you have and work from there. Another type of problem you can expect to see would be, given a situation like this, what value of x would make line M parallel to line N? So right now, we do not know that these lines are parallel. They look like they could be. We want to know what value of x would make them be parallel. So in this case, what we have to think about is, given this angle and this angle, what relationship should they have? So these angles right here are same side interiors. And we know that if M and N are going to be parallel, we need those same side interiors to add up to 180. So if I take 3x minus 15 plus 150, that should equal 180 degrees. And now all I have to do is solve my equation for x. So if I take 150 minus 15, I get 135. Subtract the 135 over, 3x would equal 45. And so x would equal 15. So if I put 15 in for x, I'm going to get same side interiors that are 180, and that will make line M parallel to line N. So on these types of problems, you're trying to think of what angle pair do I have and what's supposed to be true about that angle pair. So same type of deal, if I want M to be parallel to N, so I don't know that these are parallel yet, but I want to find a value of x that would make it happen. So again, I look at my angles. So this angle and this angle, if I look at what type of pairing they are, those are corresponding. And so corresponding angles are supposed to be equal to each other. So I have 2x plus 15 has to be equal to 135. And then I can set up or solve my equation from here. I subtract 15 from both sides. 2x is equal to 120. And so x would have to equal 60 if those are parallel. So when you're given a situation like this, you just have to figure out, okay, what angle pair do I have and what's supposed to be true? Are they supposed to be equal or supposed to add up to 180 and then solve? Okay? Now, if we want, or look at some proofs here. So I have these proofs kind of filled out. We're going to talk them through step by step. So in the types of proofs that we're working with here, they're telling us that angle 1 and angle 3 are supplementary. So angle 1 here is supplementary to angle 3. So they're starting us with those two angles. Now, those two angles are not a special angle pair. So that's not an angle pair that we know about, so I can't use those directly to show M and N are parallel, and that's what we're trying to prove right here. We want to show that M and N are parallel to each other. So, as with any proof, we start with the given information. So step 1, copy what they gave you. Angle 1 and angle 3 are supplementary. The reason, it was given. Now, when we talk about these types of problems, we said with proofs, if they give us a vocabulary term like supplementary, then our very next step is going to be the definition of that term. So supplementary means add to 180. So angle 1 plus angle 3 has to equal 180. Now, at this point, I'm trying to prove, so here we got to keep coming back to what are we trying to prove here? I'm trying to show that M and N are parallel to each other. Well, the only way to do that is find a relationship between angle 2 and angle 3. So right now, I have 1 and 3. I need to bring angle 2 into the conversation. And so if I look at my picture here, I notice that angle 2 is vertical to angle 1. These two angles are vertical angles, which means angle 1 has to be equal to angle 2 because they're vertical angles. So now I have angle 2 in the picture. Well, so if I'm looking at that then, angle 1 and angle 2 are the same. So if I come back up to this step 2 here, instead of saying 1 plus 3 equals 180, I can say 2 plus 3 equals 180. And there's my substitution. I replaced angle 1 with angle 2. Well, if angle 2 and angle 3 add up to 180, then by definition, angle 2 and angle 3 are supplementary. And if angle 2 and angle 3 are supplementary, then my line M is parallel to line N because of same side interior angles. So when you're looking at trying to prove that the lines are parallel, you have to figure out, okay, what angle pair can I find in my picture? Can I find same side interiors? Then I want to show they add up to 180. Can I find corresponding angles? Then I want to show that those corresponding angles are congruent, and so on. So it's all a matter of finding those angle pairs to determine or show that they follow the pattern they're supposed to. So here's another proof. So on this proof here, so here's my given information, which means that's the first thing I'm going to write down in my proof. So before I even start my proof, I know what I'm going to be starting with. So I know the first line is A is parallel to B and L is parallel to M. That was given to us. Now that's very helpful because they're telling us this line is parallel to this line. It's telling us that this line is parallel to this line. So that means I pretty much have free range of using angle pairs. I can jump from group to group to group however I want because I can jump from parallel line to parallel line. Now, the one thing I want to caution you on, and this is something that a lot of kids try to do, I cannot take angles from this top corner here, for instance, and go directly to these angles down here. There's no line connecting those two segments or those two sets of angles. So I need a road to travel to get from one angle set to the other. So when you're looking at these types of problems, if I don't have a line going from one set to the other, if I don't have a road to travel to, there's no way I can cut those together. Okay? So we got to keep that in mind as we go through here, because what they're trying to have us do, and I'm going to put this in yellow here, they want us to show that angle 1 is congruent to angle 16. That's our goal. But as I just said, there's nothing that allows me to go directly from 1 to 16 here because they don't have a road to travel along. So there's no connection directly from 1 to 16, so we got to figure out a different way to go. So in my proof here, if we take a look at kind of what I did, I started by saying, well, angle 1 is congruent to angle 8. If I have parallel lines everywhere, I can say angle 1 is congruent to angle 8 because they're alternate exterior angles. Since my lines are parallel, I have all my angle pairs to work with. So 1 and 8 are congruent because of alternate exterior. So I have angle 1. That's the start because that's what I need to have in my proof statement is angle 1. Now I need a way to put angle 16 in. So I'm missing angle 16 right now. So if I look at my picture though, because of my parallel lines, angle 8 and angle 16 have to be congruent to each other because they're corresponding. So because I have my parallel lines, those corresponding angles have to be congruent to one another. And so now I have 16 in the picture, which is what I need for my proof. I need angle 1 to be congruent to angle 16. Well, so now if I look at what happened here, I went from angle 1 to angle 8, and then from angle 8 to angle 16. So if I follow that path, 1 to 2, 2 to 3, I can go straight to 1 to 16 using that transitive property, that middleman. So I'm just eliminating the repeated angle 8. 1 and 16 have to be the same by transitive. And this will be the primary proof for this type of problem. When you have two sets of parallel lines, it's going to be some type of transitive. I'm going to follow this angle to this angle to the next, until I finally get the angles I need within the problem. Now, let's take a look at that same proof again. So again, I'm going to highlight in yellow what we're trying to show here. We're trying to show that angle 1 is congruent to angle 16. We have the same information as before, so they're telling us that A is parallel to B and L is parallel to M. So exact same proof, like nothing has changed. But if we look at how I went about solving it this time, so the first thing I did this time was I said angle 1 is congruent to angle 9. So I have to have angle 1 in my picture, so I bring it in right here. Angle 1 is congruent to angle 9, which I knew because those two angles are corresponding angles. So angle 1 I have in the conversation. Now I need angle 16. So if I look at 16, I notice, well, 9 and 16 are alternate exterior angles, which means 9 and 16 have to be identical. And so here I bring 16 into the conversation, just like I needed. And then exactly like the last proof, 1 led to 9, 9 led to 16. I can get rid of that extra 9. 1 goes to 16 by transitive. So with these proofs, there's lots of different ways to get from step 1 to step A to step B or whatever. You can use any angle pairs that you need to, as long as both sets of lines are parallel. Now, if we look at this next proof, this one's a little bit different here, because in this particular instance, they're telling us A is parallel to B, so this line is parallel to this line. And then they're telling us angle 1 is congruent to angle 13. So that's what this piece is. Angle 1 is congruent to angle 13. What they want us to show, so I'm going to put it in yellow again, they want us to show L is parallel to M. So I want to show that this line is parallel to this line. So the yellow is something we don't have yet. So here's the deal with this type of problem. Because we don't know about L and M yet, that's what we're trying to show, I cannot jump from left to right. There's no way I can go from one angle on the left to an angle on the right using my alternate interiors or using my corresponding or anything like that. I can only jump from parallel line to parallel line. So if I look at my proof here, I can't go from 1 to 9, for instance. So I can't jump from angle 1 to angle 9 because I don't have parallel lines that way. But I can jump from this top group directly down below. So I chose to use angle 8, and that's just an arbitrary choice. I could have used a couple of different angles there, but I said angle 1 is congruent to angle 8, and I knew that because they were alternate exterior angles. So now again, we're trying to show that L and M are parallel, so I need to show an angle pair that we know about is congruent to each other. So take a look here. In the first statement, we had angle 1 and angle 13 were congruent. So 13 and 1 were the same. And then I have 1 going to 8 in the second step. So if 13 and 1 and 8 and 1 are pairs, I can eliminate that extra 1. 8 and 13 must be congruent by transitive. And I can see that in my picture too. I had 8 marked the same as angle 13. So that's my transitive property. Well, 8 and 13 are alternate interior angles. And since I just showed that those alternate interiors are congruent, I have line L is parallel to line M. So in a situation like this where only one set of lines are parallel, we have to be a little more careful. I can only jump from parallel to parallel, and then I need to use transitive to figure out how to get one of my angle pairs congruent. So I need to either show that corresponding are the same, or alternate interior are the same, or so on, or same side interiors add up to 180. So it's a little bit different than the previous one because I can't just jump anywhere like I could before. I can only jump from parallel to parallel. So let's take a look at another one like that. So on this next proof here, same type of setup. A is parallel to B, so this line on top is parallel to this line on bottom. And then this time they give us angle 11 is congruent to angle 6. So angle 11 here is congruent to angle 6 here. So that's what I know. Anything in purple is what I already know. What I want to show is that L is parallel to M. I want to show that this line is parallel to this line again. So the only way to do that is to figure out how to connect these lines, because right now I can't go between those two lines. Like I can't jump from 11 to 3. That's not a possibility. Okay, I can only jump from parallel to parallel line. So if I look at the proof that I've written out, so keep in mind 11 and 6 are already congruent to each other. Now, if I'm going to go from 11, or if I'm going to start, so in the proof I said angle 3 is congruent to angle 6, because right now I can only jump top to bottom. So I said angle 6 and angle 3 are congruent because if I look at the picture closely, those are alternate interiors. So 3 and 6 are going to be congruent to each other because of that. Now if I look at my statements, I had 11 and 6 and 3 and 6. I can get rid of that extra 6, and 3 and 11 have to be congruent to each other by transitive again. It's just that middleman. Well, if I look at 3 and 11, those are corresponding angles. And so if corresponding angles are congruent, then my two lines that I wanted to be parallel will be. So a lot of these proofs are going to revolve around like that transitive property. This angle leads to this angle leads to this angle by transitive, and then it's a matter of, are the lines parallel, or do I have the right relationship that I need? Okay? So with that, you should be able to work on the worksheet that you get in class. As you work on the worksheet, make sure you ask questions, either in class, email, whatever you need to do there. If you weren't in class, make sure you go online and get the worksheet from Google Classroom. Make sure you can either open it up and work on another sheet of paper, or you can print it out, however you want to do that. But make sure you start working through some of those problems there, working with these different angle pairs and parallel lines.